Question number 2. The question says a graph of an exponential function is shown below. So this is the graph of that exponential function, all right? So it says which function best represents this graph, okay? So let's identify some key features of this graph that will help me to identify what this function would be, okay? So if you see, this graph has a y-intercept at this point right here, okay? So at this point, when y is -3, that's where the y-intercept is. So the y-intercept would be 0, -3, okay? It also has an x-intercept, all right? So the x-intercept would be right here, okay? And that coordinate for the x-intercept would be 2, 0, all right? Because again, the x-intercept is when y is 0, all right? So those are some key features that I can identify when looking at my graph, okay? So essentially, guys, when my x is 0, my y-intercept needs to be -3, okay? So looking at my functions, if I made x 0 here, I would have 2 to the 0 power -3, okay? Anything to the 0 power is 1, so 2 to the 0 power is 1. 1 minus 3 is -2, okay? So in this case, if I replace x with 0, I would get -2 for my first equation. So I know, guys, just by that fact alone, that this is not correct. This is not going to be correct, okay? So now I'm going to test it for the next equation. I'm going to make x 0 because I'm going to look for the y-intercept. So if I make x 0, I would have 2 to the 0 power -4. Anything to the 0 power is 1, and then we're going to write the -4. 1 minus 4 is -3. Because we got -3 when we plugged in 0 for x, this would be the result for the equation that represents my function, all right? All the other ones would be incorrect because 2 to the 0 minus 1 will give me 2 to the -1, and then anything to the -1 power means you write it as a fraction. So that would be 1 over 2, okay? This would also be incorrect because you'll be doing 0 plus 1, and then 0 plus 1 is 1, 2 to the first power is just 2. Here it would be incorrect because if I plugged in 0, all right, I would end up, actually this could possibly be correct. However, guys, what does this look like? This look like y equal mx plus b, and mx plus b is linear, all right? So again, this would mean linear, so that's why this one would be off, okay? So again, all of these would be off, okay? So let's go and let's identify these answers down here. So it says identify the domain, okay? So it says which statement describes the function. We need to first identify what the domain is. So when looking at our function, guys, domain are your x values. So this is my x-axis. So I'm going to look at my function as it travels from left to right. So if I look at my function, it starts here, all right, at this right here. And if you see, we see an arrow here. So that means it's going more and more to the left. It's going to -infinity, okay? We follow our graph, and if our graph was larger and larger, it would extend forever to the right, so it would be going to +infinity. So that's where my function is going, from -infinity to +infinity for my domain, which is x, okay? So the answer I would select would be this one, because again, it's going from -infinity to +infinity, because we're going from left to right, okay? This one would be wrong, okay? So looking at the range, so the range are your y values, all right? So looking at the range, we're going to look from top to bottom. So if I look from the top, it's starting all the way up here, or rather from bottom to top, sorry, okay? So if we look from bottom to top, we would be starting right here because our graph doesn't extend all the way to bottom. So it would be starting right here at this line at -4. And then it will be going upwards forever. Because it's going upward forever, we see an arrow. That means it's going to +infinity, all right? So it's all the numbers that are bigger than -4. So this would not be correct because we're not starting at negative infinity, guys. All right, we're starting at -4. So this is where my line started, at -4. So I would say it's all the numbers bigger than -4. So this will be the result. Okay, this is incorrect. All right. So the next one says the function has a constant rate of change, and then the other one says the function does not have a constant rate of change. A constant rate of change means that your function is changing by the same amount every time. If you see here, it was going in a straight line at first, but then it started to go rigorously upwards. So that is not a constant rate of change. This rate of change is sporadic, all right? So again, guys, this would not have a constant rate of change, all right? And then the final thing is that it's asking you what the asymptote is. So it's asking you, where is your function approaching but never crossing? So it seems that it's approaching this right here when y is -4. All right? So in this case, it's approaching when y is -4. If we looked at when x is -4, that would be right here. So this is when x equals -4. And if you realize, we did not even go close to that. But we did go close to when y is -4. All right? So again, this is where x equals -4. And our graph doesn't even go near where that is. Okay? But it does go near here when y is -4. So in this case, this would be the result. This is incorrect. All right? So good luck, guys.